This lesson is section 2.1, Inductive Reasoning and Conjecture. Our learning objective for today will be to make conjectures using inductive reasoning and find counterexamples. So, the whole basis of our lesson today is that we are going to be trying to find patterns and then make guesses based off of those patterns. So our first example says, how many dots would the next picture have? Well, in order to do this, we first need to see how many dots each figure has. So the first figure has 2 dots, the next one has 6 dots, the one after that has 11, and then the following one has 17. So to find the pattern, let's look at how many dots are added each time. Well, from 2 to 6 there are 4 dots added, from 6 to 11 there are 5 dots added, and from 11 to 17 there are 6 dots added. So we can definitely see a pattern here. Each time the difference between the dots is going up by 1. So you could assume that the next picture would be adding 7 dots, which would mean it would have 24 dots total. Next, here we have a list of numbers. What will be the next number in the series and how do you know? So again, first try to find the difference between the numbers. Between 4 and 10, we're adding 6. Between 10 and 18, we're adding 8. 18 to 28, we're adding 10. And 28 to 40, we are adding 12. Here we can see a pattern between the differences. Each time you are going to add 2 more than the previous time. So you could assume that you're going to add 14 to 40, which would give you 54, because the difference is increasing by 2 each time. Notice I asked you to say, how do you know at the end? Some questions will just ask you for the next number. Other questions will say, how do you know that's the next number? So, what were we just doing in those 2 examples? We were using inductive reasoning. Inductive reasoning is reasoning that uses a number of specific examples to arrive at a conclusion. A conjecture is a concluding statement reached using inductive reasoning. It's an educated guess. So our 2 answers on the previous slides were both conjectures, and we had to use inductive reasoning in order to arrive at those conjectures. So steps for inductive reasoning. First, you're going to want to look for a pattern. Second, you're going to want to make a conjecture. And then third, you're going to want to test your conjecture to make sure it makes sense. Our first example. Write a conjecture that describes the pattern, then use your conjecture to find the next term. So first we're looking at movie times. 8:30, 9:45, 11, 12:15. We need to find out what the pattern is. In order to do that, you need to find the difference between each of these different movie times. You can see that it's going up by an hour and 15 minutes each time, so that's going to be our pattern. 1 hour and 15 minutes between each show. The conjecture is what we're going to use to describe what the next movie time is going to be. It's our educated guess. So the next show time is 1 hour and 15 minutes greater than the previous show time, so the next show time will be at 1:30. So we used inductive reasoning to make a conjecture about what the next movie time will be. What conjecture can you make about the sum of 2 odd numbers? So remember, in inductive reasoning, you need to look at specific examples. If specific examples are not given to you, you need to write your own examples. So let's go ahead and add together some odd numbers. 3 plus 3 is 6, 9 plus 5 is 14, 1 plus 5 is 6, and 7 plus 3 is 10. Do you guys notice any similarity between all of these different sums? Well, one conjecture that you can make is that the sum of 2 odd numbers is an even number. Notice that no matter what 2 odd numbers you add together, you will always get an even number. Alright, I want you to pause the video and try these three on your own, then play the video to see the answers. Make a conjecture about each of the following: the sum of an odd number and an even number. Remember, you need to try out some examples. 1 plus 2 is 3. 5 plus 4 is 9. What you'll notice is that all of your sums are going to be odd. Next, the relationship between AB and EF if AB is equal to CD and CD is equal to EF. Well, if both of those segments are equal to the same segment, we can say that AB is equal to EF. Say that AB was 6, that would mean that CD was 6. If CD was 6, then EF would be 6, because they're equal and equal. The relationship between the points L, M, and N, if LM is 20, MN is 6, and LN is 14. On this one, you're going to want to draw a picture. So first I'm going to draw a line segment with 3 points. I can see that LM is the longest, so that's probably going to be the whole length of this. So let's start with MN. I'm going to fill in MN right here. And I know that MN's length is 6. If this is N, then this has to be L, so I can get my LN in there. Then I fill in my lengths and see if this works out. MN is 6, LN is 14, and LM, the whole thing, is 20. So what's the relationship between these points? It's that N has to be between M and L for this to work out. Now we're going to talk about making conjectures from data. The table shows the total sales for the first 3 months in its stores open. The owner wants to predict the sales for the 4th month. So you could look at these numbers and try to predict what the next one would be, but another option is to make a graph. After you make the graph, it'll be really easy to make a conjecture about the sales for the 4th month. So here's our example. We have our table. We're going to make a graph based on that table, and we can see the upward trend. And then we're going to guess what the next month's sales is. Well, if you notice, the numbers are being multiplied by 3 every time, and we can see they're going up exponentially. So what we're going to do is multiply that by 3, or you could try drawing a curve through these points and see where it crossed the 4. And we would get that the sales for the 4th month would be 13,500 because the sales are tripling. Is each statement true or false? If it is February, then there are only 28 days in the month. This is false. The reason why it's false is because leap years, there's 29 days. Next, if a figure has opposite sides parallel, then it is a square. It is true that squares have opposite sides parallel, but there are also other figures that have opposite sides parallel, like parallelograms and rectangles, so this is also going to be false, because there are other figures. Last one, if a figure has 4 congruent sides, then it is a square. So it is true that a square has 4 congruent sides, but there are other examples. For example, a rhombus has 4 congruent sides, so this is going to be false. So why were we just deciding true and false on those previous cases? It's because we were learning how to find a counterexample. A counterexample is a false example used to disprove something. So let's try finding counterexamples. Find a counterexample to show that each conjecture is false. If n is a real number, then n squared is greater than n. So, say I pick 2. 2 squared is 4, and that's greater than 2. You're just picking a number for n. So that's true. We're trying to find an example that's false. Well, what happens when we plug in 1? 1 squared is 1, and that's not greater than 1, so false. If n equals 1, then the conjecture is false. Another example you could have used was 0. Next one. If jk equals kl, then k is the midpoint of jl. This one is a tricky one. Remember that you were trying to find a counterexample. So don't just draw a line with k being the midpoint. We're trying to find an example where this would not be true. Here it is. It does not tell us that k is between j and l, so we could draw a picture like this, where jk and kl are congruent, but it's not the midpoint. A midpoint has to be on a line segment, and this is two separate line segments.